Hi, let's talk about Sedenius Signal Plot Components. What are Sedenius Signal Plot Components? Signal Plot Components offer you the possibility to clearly visualize your technical data. This includes, but is not restricted to vehicle bus data. This makes Sedenius Signal Plot Components the ideal tools for troubleshooting and detecting irregularities. In addition to a graph-based display, sophisticated tools for difference measurement and frequency analysis are available. Signal Plot Components is a C++ library that offers easy integration in your own project. If you are looking for a convenient solution to properly visualize your vehicle bus data in ADTF, there is also an ADTF service plugin available offering the same functionality. Signal Plot Components is about visualizing and analyzing prepared decoded data. This can be done by setting up a data pipeline and include the Sedenius Signal Plot library for the visualization. Jumping right in, let's start with the Signal Browser. Signal Browser's primary function is to list down all the available signals that can be analyzed. Here we can see a bunch of signals that the data pipeline is processing. Supported signals include some IP, CAN FD, FlexRay, ROS, but are not restricted to those mentioned. If you have your data at hand in CSV format, you can load the CSV and visualize the included signals. Via drag and drop we can easily get the signals we are interested in into the Signal Monitor. Signal Monitor displays signal values and their statistical calculations like average, minimum, maximum, and standard deviation. If we are receiving live data, the values are updated accordingly. We can export the live data that's selected in Signal Monitor by recording and saving the record. This way we can easily replay and analyze parts of the live data later on. To visualize the data from Signal Monitor in a plot, you check the box to plot data for the desired signal in Signal Monitor. By default the data is sent to the Signal Plot 1 window. By right-clicking the checkbox you can also create new windows and send every signal to a separate window. All windows in the application are responsive and can be laid out as you wish. The curve of the second graph shows another important feature for debugging. In your data there is the possibility to have the same data point being sent multiple times. In a normal plot this will go unnoticed and can lead to serious problems while being hard to troubleshoot. In our signal plot the data points are marked by their instances of occurrence. Looking back at the Signal Monitor, we have a lot of options to customize the plot to our needs. We can adjust the color of the curve. We can change the curve style and choose between showing only the actual data points or different interpolation variants. And don't forget to adjust the symbol style of the data points to your liking. Let's clean up the visualization again for the next topic. Now let us have a look at the buttons at the top of the Signal Plot window. First up we have the Auto Forward button. For incoming live data this gives us the option to scroll along the x-axis and always present the newest data. Next up we have multiple zoom functionalities to separately adjust the axes to your liking by using the mouse wheel. Also per default the auto scaling for the y-axis is active to automatically scale within the before seen minimum and maximum. For further analysis of your data you can use the difference tool to visualize the value and time difference between two selected timestamps. Also vertical and horizontal inspection lines can be drawn to assist your analysis. Multiple signals can be added to the same window resulting in multiple axes being automatically scaled, but there is also the option to use a single y-axis for all signals. Last up you can add a title to the plot and save an image using the current scaling settings. Another useful tool to track the status of multiple signals at once is the Signal Table View. Per default it is stacked in the same window as the signal plot, but can be arranged as needed. Simply drop the signals you are interested in from the Signal Browser to the table view. You can see the current value of all signals being added. Let us add an expression to the signal to be visually assisted once the signal value is in the defined range. The values for this signal range between 0 and 2. I want to see when the value is greater than 1.5. The last tool is the histogram table view. Just add the signals from Signal Browser that you are interested in again. You can also filter the available signals. Set the color and define the expression that should be tracked. You can show or hide, and reset each signal histogram individually, or reset them all at once. Finally, there is again the option to set a title and save an image of the histogram. Thank you for watching. For further details about functionalities or licensing, contact us at sales@sedenius.com.